Alright, let's try one where we actually have a quadratic factor in the denominator. So right now we have a denominator of x cubed plus 1, which can factor. And if you're not sure how that factors, because you don't remember the sum of cubes formula that you came across at some point, if you know anything about polynomials, you know that if you plug in a number and it makes that expression 0, that polynomial 0, then you have found a 0 of that polynomial. So for instance, if you plug in -1 into the denominator, you get 0, which suggests that x plus 1 divides the denominator. And so you can figure out what would remain by doing synthetic division. So 1x cubed, 0x squared, 0x plus 1. And again, just doing synthetic division here. That's not a -1. We get x squared minus x plus 1. Now that right expression, x squared minus x plus 1, is an irreducible quadratic, so we can't factor that. So we're going to have to do the composition with it as is. So it can be written now. We can rewrite this as a over x plus 1 plus bx plus c over the irreducible quadratic. Alright, and so then we think of what the common denominator is. The common denominator is x plus 1 times x squared minus x plus 1. This first term is lacking the x squared minus x plus 1. And the right term is lacking the x plus 1. Now, with the denominators the same, we can ignore them. So now I've got my equation 2x squared minus 4x plus 3 is equal to a times x squared minus x plus 1 plus bx plus c times x plus 1. Now what I'm going to do, I think I'm going to do it a little differently this time. Last couple times I plugged in convenient values for x, which we could do. We could plug in -1 and that'll help us find a. But I might do that later. What I'm going to do first, just to give you another idea that you can use, you can distribute this a you can expand by multiply these two terms together and get bx squared plus cx plus bx plus c. And then what you can do is collect the terms as coefficients. So I've got an ax squared and a bx squared. So together that would make it a plus b x squared. I've got a -ax and a cx and a bx. So that would make a b plus c minus ax. And then as constants, I have an a and a c. So what this allows us to do is we can now equate the corresponding values. So the x squared term is a plus b, that must be a 2. So we know that a plus b must be 2. We know that b plus c minus a must give us a -4 because that's in front of the linear term. And we know that a plus c has to be a 3. So now we've got a system of 3 equations with 3 unknowns, which can be solved using a calculator if you wanted to use matrices. But if you don't want to do that, which I don't think I want to do it. I think there's a quicker way in this particular problem. What I think I'm going to do is I'm just going to find out what A is, because when I find out what A is, the first equation will tell me what B is, and the last equation will tell me what C is. And then the second equation we can use as a check for consistency. So let's plug in negative 1, because when x is negative 1, the left-hand side of our original equation up there gives you 2 plus 4 plus 3, which is 9. And then the right-hand side, the bx plus c times x plus 1 term goes away, and I've got 3a. So that suggests that a is 3. So now that I know a is 3, I know that I can plug it in here. So 3 plus b is equal to 2, which means b equals negative 1. And I also know that a plus, I can plug it in here as well. I know that 3 plus c is equal to 3, which means that c is equal to 0. And I also know that, so now I have a, b, and c. Let's just check the middle equation for consistency. Is it true that negative 1 plus 0 minus a, which is 3, is equal to negative 4? Yes. So now I know that my decomposition looks like this. 2x squared minus 4x plus 3 divided by x cubed plus 1. That can be written as a over x plus 1, which is 3 over x plus 1, and plus bx plus c over x squared minus x plus 1, and b was a negative 1, so negative 1x over x squared minus x plus 1. So there's an example with our irreducible quadratic term. Here's some examples you can try. If you want to see if you got the answer right, just punch the original rational expression into Wolfram alpha, and you can even just write, decomposition of, and then type in the expression, and it'll decompose it for you. So you can do that to see if you got it right.